This is Submodule 1-5, Absolute Value Equations. Okay, absolute value, you may have had some in Algebra 1. We're going to talk about absolute value. You put it in the absolute value bars. And it means a number's distance from 0 on the number line. So, if it says the absolute value of x is equal to 5, that means any value that's 5 units from 0 on the number line. Well, that could be 5. That could be 5, but if you go in the other direction, 3, 4, 5, -5 is also 5 units from 0. So it could be, x could either be 5 or -5. Okay. All right. If we are talking about solving an equation, an absolute value equation, you're going to use that. You're going to say, okay, I'm going to drop the absolute values off the left-hand side. And it's going to either equal 5 or it's going to equal -5. So now you have two little equations to solve. And I'm just going to, one-step equation. So x could either be 4 or it could be -6. This is not an ordered pair. It is a solution set, so we put it in the little squiggly braces. If you wrote -6, 4, that's also correct. Okay, when we're solving absolute values equations, we must always isolate the absolute value first. Isolate means get it by itself. So like this has a +5. We got to get rid of that. So we're going to -5. Okay, so now we have the absolute value by itself. So it's either equal to 4 or it's equal to -4. And you're just going to solve the equation. Okay, so we have y is either 0 or it is 4. Okay, but sometimes you may get what's called an extraneous solution. An extraneous solution is a solution derived from the original equation that is not a solution to the original equation. And there are several times throughout the year that this is going to occur, that we could have an extraneous solution. This is just the first one. Another way to explain it is a false solution. It may come up, it looks like an answer, but it's really not. Okay, for absolute value equations, this is only going to occur in equations that look like these. Okay, what's different about this than the ones that came above it? Well, it has a variable that's outside of the absolute value. Those are the ones that you've got to check for extraneous solutions. Okay, so we have the absolute value is isolated. So we have to set it equal to the positive of the right-hand side. And we have to set it equal to the negative of the right-hand side. Okay, and then we're going to solve the equation. Okay, and then for this one, we have to distribute the negative. Okay, so I've got two answers. Looks like just the, like the others. But we have to check, and there's one thing that we need to know about absolute value, and that is an absolute value cannot equal a negative. So if we look back up here at these answers, now you can check it back into both sides, but you don't have to. You can check just into this side. If this comes up a negative, it can't be an answer. So if I want to check, I'm checking negative 15. If I do 3 times negative 15, that's negative 45 plus 10. That's a negative, so that's bad. That one doesn't work. Now, we're going to be checking x is negative 1. 3 times negative 1 plus 10, that's a 7. Okay, so that one works. So the only answer is the negative 1. The negative 15 was extraneous or false. Okay, for example 4, you have to isolate the absolute value. Okay, set it equal to the positive and equal to the set it equal to the positive and equal to the negative. Okay, so then we're going to solve. Okay, and again we're going to check them, and I'm going to check it into 2x plus 5. So I'll put that into 2x plus 5. That's negative 8 plus 5. Oh, that's a negative. Doesn't work. Let's try this one. Negative 4 plus 5. That one checks, so your only answer is a negative 2. Now, does that mean if it has a variable on both sides that you have to have an extraneous solution? No. Okay, you can have one like this and both of them work, and that's okay. I just looked for problems that had that just to, have multiple examples of checking for an extraneous. Okay, as we said, an absolute value cannot equal a negative. So that makes some problems very, very easy. If you ever get in this situation where you have the absolute values, nothing else with it, an equal sign, and a negative number, you're done. Because absolute value cannot equal a negative. So if I say I want to isolate, that's a negative 2 times the absolute value. So to get rid of it, I have to divide. Okay, absolute value, equal sign, negative number, I'm done. That can't happen. Okay, there's no number that I can put in here that then I can take the absolute value of and get a negative. So there's no solution. Okay, so anytime you end up with an absolute value equal to a negative number, there's nothing else attached, it's no solution. Okay, for this one, if we isolate, let's see, what is that, negative 32? Doesn't really matter, I know it's a negative, so it's no solution.